Hey folks, so in this video we're going to be doing a little bit of review. So what I want to talk about here is the basic data structure, the basic collection called a stack. And this is kind of going to be for our use later on, right? I want to kind of make sure we're on the same page on what this thing does before we go and start doing more complicated things with it. So stack hopefully is something you've seen maybe in like a previous class, for example your core data structures class before this or your OOP class before this. One of those classes should have covered this. So what is a stack? So a stack basically is it's a type of container or a type of collection. It's a way to store and structure data. So I have a graphic here. Maybe we'll start with a graphic before we even look at the text. This is kind of the familiar way that people maybe draw out a stack. There's the idea basically that you have pieces of data, right? And your pieces of data basically are stacked on top of one another, right? So here I have this stack. Let me just write in things. Let's say I have maybe a stack of letters, right? So I could have A, B, C, D, E, F, right? Maybe G is going in, Z is coming out. I don't know. Somehow there's this idea, right, that you have a collection of items, right? So maybe you start thinking of like, oh, it's, the most basic collection, right, I can think about is something like an array. Well, the idea here, right, is I have, a place or a way to store things, right, what I'm referring to generically kind of as a collection, that has rules behind it, right? So an array, basically, I can reach it, I can grab whatever I want from any index. Right? I can grab from index 1, I can write to it, I can read from it, I can do whatever I want, right? There's no kind of restrictions that tell me, oh, I need to access an array in a certain way, right? I'm just free to do whatever I want. Here's a little bit different. Here's different because there are actually rules, right? And so this bottom part, right, you can see I have these things, right, one after another. There's kind of an order behind the scenes, right? This is actually an ordered collection, right? So it matters that I have A, then B, then C, then D, then E, right? That order matters, right? I can do different things based on what that order is. And this is very different, right, from an array where I can just, act on any element that I want. So here what I deal with is that there's basically a rule, right? And a rule that says how I can add things, how I can remove things. So the rule is add to the top, take from the top, right? And you can see that in the graphic, right? So you can see G, I'm doing what they call a push, which is the name for when we add an element to a stack. And that arrow is pointing at the top, right? It's pointing at the letter F, right? The idea being is that G will be put on top of F, right? That's the only place I'm allowed to add. So I'm not allowed to add, in the middle or at the end or anywhere else. I can only add at that one point, right? I can only add at the end. In addition to that, I can only take from the end, right? So you can see I have pop there, there's another arrow. If I want to take information out, it has to come from the top. I can't reach to the bottom, I can't reach into the middle, it has to come from the top, right? So I put in something on the top, take out something from the top. You can maybe visualize this as being something like a stack of dishes or a stack of books, right? Maybe a stack of dishes is the best, right? For a stack of books, you can maybe imagine pulling out one book from the middle. For dishes, you're probably going to end up with just a huge mess if you try to do that, right? So it's a stack of things, right? Items one after another, where I can only add to the top, where I can only take from the top. Okay, so that's the basic concept here. So it is ordered, right? The order matters because we have to basically remember, in a sense, who went in first, who came out, right? We need to know, right, that B was added after A, that C was added after B, right? We have to remember that. That order is important to us, it matters to us, and so we'll have to keep track of the order of these things. So it's ordered. Stacks can allow duplicates, right, which is good. I didn't draw anything here, right, but I could have, be push on A again, right? And it would be a different A than that bottommost A, right? That would be fair game. So it allows duplicates. This is what we call, in kind of typical speak, this is a LIFO or a last in, first out collection, right? That's the rule that governs it, right? And that's coming from the fact that we add something to the top, that's going to be the first thing we take back out, right? So the last thing we've added is the first thing we take off, okay? All right, you'll hear that term, in different places, right? That's kind of just a short way of referring to the rule. For us, we'll just generally say stack, though. All right, so if you want, you can also go and check out, basically, there's an implementation of this, right? So in the Java library, right, stacks are very common. So unsurprisingly, they've implemented stacks already. I mean, they've also implemented queues as well, right? They've implemented all sorts of things. So if you want, you can go and check out what the stack is in Java, although it may not be as interesting as you would hope. But it is there. Now, for us, what we care about is basically the stack that's defined in basically the textbook by Sedgwick, which is this over here. So this is a basic interface for a stack. It's what they call, here they have the word pushdown stack, because it's just another way of talking about it, right? Pushdown is you're putting it on top, right? Putting it down, pushing it down. So here's the basic implementation, and this is what we care about in our class, right? So we're not going to use the Java one, we're going to basically make up our own one from these basic parts. So, okay, so I have basically a constructor, always have a constructor. We have a push and a pop, right? So these are our ways either to add elements or to remove elements, right? And the add element one is very generic. It literally just says add an element. The remove one's a little bit more specific. Notice it says remove the most recently added one, right? That's where we get our stack-like LIFO mechanic out of, right? That from having that rule there. Let's see here. So I have is empty, right, which is basically returning a boolean, am I empty or not? And then another one to check to see what is the size, right? How many things are in there. All right, this is our basic interface. This is what we're going to be implementing later on. All right, so as a quick note here, or actually a couple notes. First of all, this API in the book is a little bit incomplete. It's also very typical to have something like peek, right? So pop is a function that basically takes the topmost element and returns it to you, right? And it's destructive. It changes the stack. It removes that topmost element. Peek is a way to glance at the top, see what's there, but not remove it, right? So it's very typical to have peek operation in a stack because it's a way of previewing what's to come and then deciding, do I want to do a pop or do I not want to do a pop? So peek's very typical, but it's not on this list. We'll be doing it later on in the course. All right, and there's also other stuff, right, we can think about doing. And this maybe comes back to some of the other discussion we've had earlier in this class, as well as some discussion still to come. But I could have, right, all these other things that get implemented, right? So these are interfaces that are being implemented, right? I could implement, serializable. I could implement clonable. I could implement iterable. These are all the different things we're going to do. The one we'll talk about a little bit is iterable, right? So we'll implement an iterable stack later on in this module. Serializable, clonable, we won't really talk about. As a reminder, right, serializable is basically supporting a way to make kind of copies of this object to the disk, right? Clonable is I want to make deep copies of it in memory, right? So I want to make, I have one stack, I want to clone it, I want to make another copy. That's what clonable supports. All right, so those are other things, right, that are very useful. We're not going to be talking about those first two. We'll just do iterable. In practice, right, you would probably implement them as well. All right, so that's all I got for you guys in this video. In the next video, we'll talk about a few examples of using a stack. In the next video, we'll talk about a few examples of using a stack.